In an earlier video, we looked at how to simplify a rational expression. So basically, we just factor the numerator, factor the denominator, and divide it out or canceled like factors. So if you had a factor in the numerator and the same factor in the denominator, you could cancel those out or divide them out. Well, multiplication and division pretty much does the same thing. So let's look at the first one here. And then I remind you that, let's say A and B are polynomials. So you have a rational expression. We factored the numerator, factored the denominator to simplify it, and then canceled out like factors. Well, for multiplication, rational expressions, say you have A over B times C over D. And again, the assumption is going to be that B and D cannot be 0. Okay, can't divide by 0. So what we do here is just like regular fractions. So you have 3/4 times, say, 5/6. We could just multiply. 3 times 5, say it's 15. 4 times 6 is 24. And then we reduce the result here. 15 and 24 have a factor of 3 in common, so if I divide 3 into 15, I get 5. And 3 into 24 goes 8. So I could just multiply the numerators, multiply the denominators, and then reduce it. Or I could just go ahead and say, well, instead of multiplying this out, let's cancel first. So 6 would be the same thing as 3 times 2. So replace the 6 by 3 times 2, and then I have one factor here that's the same as 1 in the bottom. We can just cancel these out. And I have left in the numerator 5, so I put 5 over here. And in the denominator, this is 4 times 2, we get 8. This is in simplified form. And that's one way to do it. The same sort of thing with multiplication of rational expressions. You could multiply the A and the C, multiply the B and the D out, and then simplify. Or sometimes it's easier to go ahead and just factor first and then do the cancellation. What happens if we have division? So let's suppose we have A over B divided by C over D. Well, this is the same thing as A over B divided by C over D. And now here I have a complex fraction now. So I'm allowed to multiply the numerator and the denominator of an expression by any non-zero value, the numerator and the denominator. Let's say I multiply this by D over C. Just the reciprocal of C over D. That's allowed as long as I do the same thing with the numerator. So then I can say, okay, this cancels out. This becomes 1, so what do I have left in the numerator? Well, it's just going to be A over B times D over C. And again, then I can multiply numerators and denominators and then reduce, or I can do some cancellation first to make it easier on the final result. So this is saying that if I have A over B divided by C over D, what we have to do is simply multiply A over B by the reciprocal of C over D. And then we simply simplify this, whatever this comes out to, and that's your answer. So in this particular case then, what we'll do, instead of, again, multiplying this out, that'll be messy. Multiplying this out, that's going to be messy. So let's just go ahead and factor the numerators all the way through and the denominator. So x squared minus 2x plus 1, that's the trinomial. There's no factors in common there. So this should be pretty straightforward, I hope for you. This is going to be x minus 1 times x minus 1. Or I can write it as x minus 1 squared. The denominator, I got x cubed plus x. I can factor out a x. Remember, always take out a common factor if you have one. So this is going to be, leave me with x squared if I take out the x there, and then if I take out the x on the second one, the system coefficient here is 1x, so if I take out the x, I'm left with 1. You can check it. X times x squared is x cubed. X times 1 is x, so that checks out. Now, okay, in the next numerator, I got a 4 common. I got 4x squared plus 4. I can take out a 4. What do I have left? I have left an x squared. Of course, 4 is 4 times 1, so if I take out the 4, I can still say that I have a 1 left over. So this is x squared plus 1. You can see that's going to check. 4 times x squared is 4x squared. 4 times 1 is 4. In the denominator, again, I have a trinomial. There's no like factors. So I just simply put my parentheses here, just like we did in an earlier video. Factor this out. So again, x squared, I can write x and x here. For 2, it's going to be 2 and 1 or 1 and 2. And because the third term is minus or negative, I can need a minus and a plus or a plus and a minus. And then I need to come out here with the middle term of 1x. So let's put the 2 here, the 1 here, and then just check your multiplication here. X times x for this one is x squared. And 2 times minus 1 is a minus 2. That checks out. And then the inner term here, minus x. And then out here, 2x. And minus x is 1x. That checks out. I have it factored out. So I'm allowed to cancel one factor in the numerator with one factor in the denominator as long as they're the same. So what do I have? I have an x squared plus 1, and up here on the second one I have an x squared plus 1. So these will cancel or divide out. This one will divide out. Now what do I have here? I have x minus 1 to the second, and here I have x minus 1 to the first. So again, I can divide out one factor of x minus 1 between these two here. So let me mark this out. That cancels out. And this cancels out with one power left. So what's left here? Okay, we got the 4, we got x minus 1, so let me put the 4 first. Normally we have the coefficient in front. So this will give me a 4, and then one factor of x minus 1 left over. In the denominator, I have an x. This canceled out. This canceled out. We got x plus 2. So it's x and x plus 2. Now we could multiply this out. In the numerator, multiply by 4. It could be 4x minus 4. And in the denominator, multiplying it out, I get x squared plus 2x. But it does say to leave the answer in factored form, so we'll just leave it and say this is the answer. Okay, that's the multiplication. Division pretty much works the same way, except we do one step, and then it becomes just like number 1 really. So let's look at the second one. This one I have it partially done just to kind of save some time, but the main problem here is x plus 3 over x squared minus 4 divided by x squared minus x minus 12 over x cubed minus 8. So I wrote it this way, and then keep in mind sometimes I'll give it to you in this format. Instead of writing the division here, I'll write it x plus 3 over x squared minus 4 quantity over x squared minus x minus 12 over x cubed minus 8. So again, like I mentioned earlier, division pretty much is the same procedure as multiplication except for one step. you have to multiply by the reciprocal of the divisor. So the divisor is this one right here. So this becomes x plus 3x, or x squared minus 4 becomes this. So it becomes x plus 3 over x squared minus 4 times the reciprocal of this. And there you have it. Then it becomes just like number 1. We factor the numerators, factor the denominators, and then cancel like factors. So the first fraction, the x plus 3, is already isolated. There's nothing I can do with that one, so I just write that as x plus 3. One factor of x plus 3. In the denominator I have x squared minus 4. Difference of two squares. We did something like that in the first video on rational expressions. If you have the difference of squares, no common factor here, so we don't have to worry about that. It factors into the difference in the sum of the square roots. So x squared minus 4 factors into x minus 2. Square root of x squared is x. The square root of 4 is 2. So this is going to be x minus 2 times x plus 2. Okay, and we have times there. And then the second fraction, the numerator is the difference of cubes. We did one involving that, pointed out what to do. If you have the difference of cubes, no common factor again, so we won't have to worry about that. Difference of cubes, the first factor becomes the difference of the cube roots. So the cube root of x cubed is x. The cube root of 8 is 2. So we have x minus 2 is the first factor. And then the second factor is always the square of the first term of this binomial. So this would be an x squared. And then you change the sign from minus here, x minus 2, make it a plus here. And it's the product of these two terms, 2 times x. That's a 2x. And then plus the second term squared. 2 squared is 4. There you have it. And then in the denominator, I have then x squared minus x minus 12. X squared minus x minus 12. There's no common factor, so since it's a quadratic binomial, or trinomial I should say, we expect that this should factor into 2 factors. So x squared, we can break it down into x and x. Because it's a minus 12 for the third term, the signs have to be different. So I have to have a minus and a plus, or a plus and a minus. And then factors of 4, or 12 rather, are 4 and 3, 6 and 2, 12 and 1. We want the combination that will give us this middle term of minus x. So the ones that will work here are going to be 4 and 3. So let me put a 4 here, and a 3 here. And then check it out. Multiplying the first terms, x times x, does give me the x squared. 3 times minus 4 does give me the minus 12. And then the inner product here, minus 4x. And over here, 3x. Minus 4x and 3x does give me minus x. So there we have it. Now it's just a matter of canceling like factors. You're allowed to cancel one factor on top, one factor in the bottom, as long as it's the same one. So here we have an x plus 3 on top. That can cancel with 1 in the bottom. Here's 1x plus 3 here, and that cancels. And then I have an x minus 2 under this one. I have an x minus 2 up here. As long as it's 1 on top and 1 on the bottom, you can cancel. These will cancel. And then this is going to equal 2. What do I have left? So on top, the only thing I have left is x squared plus 2x plus 4. And in the bottom, we have left x plus 2 and an x minus 4. So we write out the x plus 2. And the x minus 4. and that is the reduced solution. Again, in some cases it might ask you to multiply out the factors x plus 2 and the x minus 4. You can multiply it out, but here it says to leave it in factored form, so this would be the final result. Thanks for watching. We'll see you next time, and also I'll go ahead and put links to the videos that are related to these types of problems in the description. See you next time.